Okay, so we are talking about the vector lesson. So first of all, what is a vector? What is a vector? So this is the first question we have to ask. So vector is a quantity. Vector is a quantity which has a direction, which has a direction and a magnitude. A quantity which has a direction and a magnitude. So magnitude means size or value, right? So what is a scalar? So I'm not going to write that. Scalar is a quantity which has a magnitude only, right? So example. So think about distance. Think about a distance and think about displacement. Distance and displacement. So distance is the length, the total length. For example, A to B, this total length. If you go through this path, the total length is distance. For example, that is 10 kilometers. Now, displacement is the shortest distance you can say. Shortest distance, and that has a specific direction. You can see specific direction, right? So this is displacement. So that would be 2 kilometers maybe. So you can say this is the displacement. Displacement. So the displacement is the shortest distance you can say. So you can see that displacement has a magnitude as well as a direction. So vector is a quantity which has a direction and a magnitude. Okay. Now, let's see how to draw a vector. So you can have a vector like this and you can name it P. So you define with arrow P, P with arrow, it's a P vector. So the P vector, the direction is from A to B. That AB direction, that means the direction is this way. So now you can't say here exactly this is north, south, northeast, southeast, because direction can be anywhere, right? So now the direction is shown here. Now what about the size of this one? Size of this one is a magnitude. Size of this one is a magnitude. So this magnitude is nothing but AB distance, and that is written as P vector magnitude. So that's a notation. Now we have an issue with the direction. We have an issue with the direction, right? So how to properly define a direction? How to properly define a direction? So this question I'm going to discuss in here. So direction is given by its unit vector. Unit vector. So I will explain to you what is unit vector means. Unit vector. Okay. Now, so this vector is P vector. I'm going to draw a unit vector which is in the same direction. So unit vector is this much. So why it is called unit vector? Because this distance is going to be unit 1. So it can be 1 meter, 1 kilometer, 1 millimeter, but the distance is unity, 1. So that we define as P hat. P hat. So P hat is the unit vector, right? P hat is the unit vector. So now we had the question that how do we define this direction? So mathematically, direction is defined by a unit vector. A unit vector in that direction. In that direction. So it would be P hat in this case. It would be p hat in this case. Okay. So now I will show you another way of thinking this. Consider this to be your u vector, u vector. Now we know that from the definition, the direction of this u vector is given by u hat. U hat is mainly used, that's a unit vector, but mainly used to define the direction. Now, we'll try to investigate about this u hat. U hat is unit vector, size of u hat. Size of u hat is unity. Unity means 1, right? So, how much is the size of this arrow? How much is the size of this arrow? Right? So, we call it size of this arrow. So, that has a name, magnitude. Magnitude. That magnitude is given by u vector magnitude. This is how you define. So, we understand that magnitude is u vector magnitude, right? So, now if you look into the diagram, if you look into this diagram, you have u vector. U vector is this size and the direction. And the direction is specifically given to you by u hat. U hat is the direction. It is called unit vector. And this distance is given to you by u vector mod. So now we have to understand there are 3 things. So this guy is defined by direction as well as its size. So based on this logic, you can say vector can be written as magnitude times direction. Magnitude times direction. So magnitude is going to be u vector mod. Direction is going to be u hat. Vector is u. So now this we constructed logically. So this is called the definition of a vector. Definition of a vector. Now let's think about an example. So I'm going to have a vector from A to B, and this vector is V vector, for example, right? And then I'm going to get half of that magnitude here. And then I'm going to say this is going to be P vector, and this is A prime point to B prime point, right? And then I'm going to have another one here, right? So I'm going to say this is A double dash point to B double dash point. Now I'm going to say this one is Q vector, right? Now, suppose the distance between this point A and B is 10. The distance between these two is 10. And the distance between these two is 5. Right? And the distance between these 2 points is unknown. Suppose lambda. Right? Lambda, unknown. Right? So then, how do we define V vector? We define V vector, its magnitude, which is 10, multiplied with what is the direction? Direction is this direction, right? What is that direction? We can't say north, south in that way. So we uniquely define the direction as V hat. So we understand when we say V hat, it is in the direction of v, which is this direction, but it is given by the unit vector. Unit vector means the size of that u hat is 1. So this is 1. Okay, so that's the definition. So now we need to define p vector r. We need to define p vector. So now the way I have p vector is that they are parallel to each other. V vector and p vector are parallel to each other. So that means you can say magnitude is 5. So I can use the direction to be the previous one, v hat. We can do that because the direction of this one is the direction of this one. So one might think of writing this 5 times p hat. Yes, you can do that. Now you will understand p hat direction and the v hat direction is the same. So this is equal to this. So you can use either. Right? Okay. So now the next one, q vector. So direction is going to be the same. What about the magnitude? Magnitude is lambda. Now we are introducing a variable, parameter we call it. Lambda times, again the direction is v hat. So lambda v hat is the vector. Let's talk about negative vectors now. Negative vectors. So this is a very easy concept. Suppose this vector is u vector here, and that is from this point to the final point. And then if you flip the direction, this can be written as minus u vector. Minus u vector. The size of this arrow is u vector magnitude. The size of this arrow, you can say minus u vector magnitude, but essentially that is u vector magnitude. Because magnitude is the plus value, right? We ignore the minus, right? So direction is flipped, so you are introducing a minus. So that is called negative vectors, right? Now, right. So another example. Suppose you have AB vector, which is going to be U vector, and there is another vector which is from P to Q, right? So this is going to be V vector, right? So we are going to say V vector magnitude divided by U vector magnitude is lambda. So what is the meaning of that? The meaning of that is, if you think about the size of this one is 1, then the size of this one is lambda. So because you can see that in here, see, 1 to lambda. So the ratio is 1 to lambda, right? So if the ratio is 1 to lambda, right, we can write V vector to be lambda times U vector. V vector is lambda times U vector. So now if you think about the magnitude of this one, then it's going to be V vector magnitude, which is the size, length, PQ, right, is equal to lambda times U vector magnitude. Right? So now we are recalling the same thing, right? So this is how you play with it. Okay, so now we know about negative vectors, right? Next, we will think about vector addition. Vector addition. So I'm going to emphasize this word vector addition, right? So the concept is this. If you have a vector from here to A to B, which is U, and when you have another vector from B to C, which is B, And when you have a vector from C to D, which is W, right? So the vector addition tells you vectors have a direction, right? So vector addition tells you that, suppose this is R vector. So R vector is equal to U vector plus V vector plus W vector. So vector addition is this. So this vector added to this vector, added to this vector. Finally, what has happened? This is the initial point. This is the final point. So this is moving from initial to final. So the shortest distance or shortest uh, way to reach D is this way, which is using R vector. So R vector is defined by this way. So this is called vector addition. So pretty simple, right? Now I need to mention to you. Now when you think about magnitudes of this one, think about the magnitudes. So if you think about the magnitudes, R vector magnitude is R vector mod. So U mod plus V mod plus W mod magnitude. So this will tell you that the size of this one, which is 5 kilometers, for example, size of this one, for example, 6, size of this one, for example, 4. If you think about this, it tells you that the size of this length is going to be 5 plus 6 plus 4, which is wrong. Which is wrong. It is not. Because 5 plus 6 plus 4 distance is a very big distance like this. Because you are adding this to this to this to, right? So there is nothing called scale addition. So whatever we understood from here is not permitted. So that's why I highlight vector addition. Vectorial you can add, but scalar wise you can't add, right? So I'm going to give you a small note here. There is no concept called scale addition. Now let's think about this example. So this is U vector and this is negative V vector, right? This is negative V vector. So now you have to think about the vector addition here. So if you think about the vector addition, it would be from here to here. So that can be U vector minus V vector, that one. So this vector is called U vector minus V vector. Now, with your knowledge, you can reverse this vector. If you reverse this vector, the resultant is going to be from here to here. Resultant is going to be from here to here. So that would be, this would be now your V vector. Positive. So now if you think about this vector now, using vector addition means what? Vector addition is you are going from here to here, and then you are going from here to here, and then the addition is this. So if you think about the vector addition, so that would be U vector plus V vector. So now this vector is U vector minus V vector. It's a totally a different vector. Now, if you reverse it, this is our construction to understand the matter. So this vector is a totally a different vector, which is called U vector plus V vector. So two different things we discussed, right? Now here we understood how to play with the negative vectors. It is our requirement. So when we construct our answer, we can have this control, right? Let's think about parallel transformation of vectors. parallel transformation of vectors. Okay. So the idea is very simple. Suppose you have a vector from A to B, and that is U. Suppose you have a vector here, I would say P to Q, and that would be V. Now I need to think about vector addition. Now the problem is the endpoint of U is here, the starting point of this one is here, right? So if you need to do the vector addition, what you have to do is you have to bring this starting point towards this, right? And then you make something like this. So to do that, this whole block, you are going to transform. So you can think in this way. So you are going to transform this up over here and this one up over here. So then this would be that. Then you are going to transform everything to left so that it matches with this. So you're going this way. So it would be something like this. So that is called parallel transformation. So in the parallel transformation, we are not going to do anything to the vector. We are not going to harm the vector. So, but this parallel transformation is a valid transformation. So then I can say you are bringing this one, this point to here. And then similarly, you are bringing this point to here. So what happened? This vector is parallelly transformed here. So that means B is going to coincide with P, and then Q comes over here, and U vector, sorry, it's V vector stays as V. So this parallel transformation is valid, right? So if you extend this idea, you will get something like this. U vector here, and then after parallel transformation, you get V vector here, and then resultant is the vector from A to Q. So this is A point. This is your Q point. So A to Q, right? I would say AQ vector. I can name it the way I want. This AQ vector is nothing but U vector plus V vector. What we were discussing, this vector, we can name it the way we want. So this endpoint, right? So the endpoints are A and B, A and Q. So we can say AQ. Or you can give a name. You can say P. So you can say this is equal to P. Doesn't really matter. This is a name. And this one also a name. So right? So it doesn't really matter. Good. Okay. So now we understand we can parallelly transform vectors, right? We can parallelly transform vectors. Now we will think about resultant vectors deeply. So this vector is a resultant vector. So you understand from the word resultant. Okay. And then in here, this vector is a resultant vector. Right? Resultant vector is what you are going to get after vector addition. Okay. Right. So let's think about a question here. Think about a simple question where you have V here and you have U here. And this is 90 degrees, right? So now we have to find the resultant vector. So what we can do, I'm going to parallelly transform this one onto this point. See, parallelly transformation. So still this is U vector, right? So then we can use the vector addition. Vector addition, you will see initial point is here, final point is here. So you will see initial point is here, final point is here. So the resultant is going to be from initial to final. So the resultant is from here to here. So how do you think about it? If you start your journey from here, you go through this way, and then you go here, and then resultant is the shortest distance. From initial to final, actually you went from I to F. So this is your resultant. That's the definition of the resultant. So now this is going to be your R vector. So in this case, your R vector is equal to V vector plus U vector. So this is true vectorially. So this is nothing but vector addition. Okay. Now we know that this is going to be 90 degrees, right? We know that this is going to be 90 degrees. And then the size of this is going to be V vector magnitude. And the size of this is going to be U vector magnitude, right? And then this angle is going to be theta, right? So now if you want to find the magnitude of R vector, so the magnitude of R vector, you can find, that means the distance of this one, scalar value, right? Distance of this one using Pythagoras theorem. So you use the Pythagoras theorem, which is going to be V vector mod squared plus U vector mod squared, square root of that. Simple Pythagoras theorem, right? Now, you can find the direction, you can find the angle, right? You can find the angle here if you want. So that theta is equal to tan inverse U magnitude divided by V magnitude. So this is the, now logically you can say this resultant vector has this much magnitude, and this resultant vector, the direction of this one is theta angle from horizontal. You can say that. So now, what would be the direction of this? Direction of this, I told you, it's going to be R hat. R hat is the direction. So this is a arbitrary direction. We don't know precisely what direction is R hat. So R hat is not like north-south specific directions. R hat is a arbitrary direction. So that arbitrary direction you can mathematically reason using this angle theta, and that is this. So R direction is theta degree from horizontal. So we'll do a question here. Find the resultant vector of the following. Find the resultant vector of the following system. So I'm going to have this vector to be P vector, and I'm going to have this vector to be Q vector. The angle between those two is theta, right? So you need to find the resultant vector of this system. So now what we are going to do, my starting point is this. My starting point is this. So I'm going to parallelly transform Q here. So I can do that. So I am going to parallelly transform this one here. Then if I do that, this is my Q, right? So this is my endpoint now. So this is my final point. Now you can make a parallelogram like this. So what is your resultant? Your resultant is from initial to final like this. This is your resultant, R. So vectorially you can say R vector, which is equal to P vector plus Q vector. Very easy. Vectorially you can write in that way. Now the problem is how to find R vector magnitude. What is R vector magnitude? R vector magnitude is this distance. How to find that? Okay. To find that, we are going to extend this here. And then this one here, I'm going to make this 90. So now you can see that this one is a right angle triangle. Then this angle is going to be theta. So the height is going to be q vector magnitude sine theta. That's SOHCAHTOA. Q vector magnitude is this distance, and then this height is q vector magnitude sine theta. That's grade 10 knowledge. So this vector, this distance is going to be q vector magnitude cos theta. Right? Q vector magnitude cos theta. So we know that the distance in here is going to be p vector magnitude, right? So now if you want to find r magnitude, r vector magnitude, which is the size of this one, what we are going to do is we are going to use Pythagoras theorem. So that's going to be this distance and this distance. So we are going to use those two distances, which we already have. So this distance is this guy plus this guy. Vertical distance is going to be just this guy. So we are going to use the Pythagoras theorem, right? I would say use P theorem. So if you use P theorem here, you will get r vector magnitude squared is equal to, your base is going to be p vector plus p vector magnitude plus q vector magnitude cosine theta, the whole thing squared, plus q vector magnitude squared sine squared theta. Right? So now we will simplify this a little bit. So r vector magnitude is equal to, now when you simplify this bracket over here, it would be p vector magnitude squared plus q vector magnitude squared cos squared theta plus 2p vector magnitude q vector magnitude cosine theta, that's grade 7 expansion, plus q vector magnitude squared sine vector sine squared, q vector magnitude squared sine squared. Now you can see these two. You can factorize, you can group them. So if you group them, it's going to be p vector squared plus, here you have q vector squared, and then you're going to write cos squared theta plus sine squared theta here. And then you have here 2 p vector q vector magnitude cosine theta. So now we know that this is a very famous trig identity, which is going to be 1. Right? So now you get, oh, I have to write square here, right? I missed that square in Pythagoras. So this is going to be now p vector squared plus q vector squared plus 2 p vector q vector cos theta. And then if you need r, take the square root of that one, and that is going to be r vector magnitude. So that's how you find the size of this vector using the given two vectors p and q. So you can see in the right hand side, you have pq only and the angle given theta, right? So if these details are not given to you, simply you can say the magnitude of r vector is this. So what we did in this calculation, we found this guy from the given data, which is q vector and p vector, using simple Pythagoras theorem.